Our second speaker this afternoon is Caroline Kroes. Caroline is the Program Manager for Corporate Strategy in the Port of Rotterdam in the Netherlands. And recently, since 2016, I think, Caroline, you've taken up a role of strategy lead for the port's energy transition program, aimed at developing a port that's in line with the Paris Agreement. Big challenge for a big port. Good luck with that. Welcome.
Good afternoon. Thank you. Let me see if I can make this work. Yes, so, well, the world agrees, not the whole world, and some American president just kind of changed his opinion, but there's a Paris Agreement. And in this Paris Agreement, we've agreed to have climate change maximized at 2 degrees Celsius, and preferably to stay as close to 1.5 degrees Celsius. And actually, we are running out of time. Right now, when I'm speaking, we are emitting lots of CO2, and it's not peaking yet. And as you can see, we are already seeing the effects of climate change and global warming. And it's already almost 1.5 degrees that we've seen warming. So last year, when the Paris Agreement was reached at Port of Rotterdam, which is very much a fossil-based port, we decided to commission a study to look into what ways the port could change, so in order to adapt and comply to the Paris Agreement. Then we thought, now what? We were inspired by a study done by the German Wuppertal Institute that they did for Germany as a whole. And that study is called Deep Decarbonisation Pathways for Germany. So we decided to go talk to them, as they had also done lots of studies for companies in the German ruhr area. And they came up with a report for us as well, Decarbonisation Pathways for the Industrial Cluster of Port of Rotterdam. And I will take you through the highlights of the study. The study can also be downloaded at our website. It's a 100-page plus report, so please feel free to read it on a free Saturday afternoon or so. So the Wuppertal Institute, they started out by modeling the Rotterdam port, and they looked at what is already present there, and they modeled that in their energy model, basically, the current industrial cluster. As you can see, there's lots of processes and factories present. Then they also looked at the kind of input that this complex used. So what kind of streams is the complex currently using to produce products, basically, the outputs. And the products would be fuels, for example, but also chemical products that would later on be used in other production facilities. And what they then showed is that currently in the Port of Rotterdam, so the cluster that's there, and that's only the factories there, it's 20% of the Dutch CO2 emissions is produced in the port. That's a lot, so that's 1/5 of the Dutch reduction, basically, that needs to be done in our port. At the same time, this cluster, of course, produces lots of products that are used everywhere. So fuels, for example, such as diesel, are being produced in the ports at the refineries. That is not part of this CO2, the total CO2 emissions. So if you drive your car and you emit CO2, then that is not part of this study, unfortunately. But 20%, it's a lot. And the good news is that Wuppertal came up with a few pathways, so a few options for the port to decarbonize. 4 pathways. One of it is business as usual, which is not really a transition or a decarbonization pathway, as it only leads to 30% CO2 emission in 2050, which is clearly not enough to comply with the Paris Agreement. Then there are three other pathways, transition pathways that lead to at least 75% CO2 reduction, and the maximum is 98%, so almost carbon neutral. The business as usual pathway is a kind of world where we do not comply with the Paris Agreement, but there's still some CO2 reduction possible in this scenario, which is mostly driven by efficiency measures. So companies, they would invest in new technologies, best available technologies. There will be some increased renewable electricity in the port, and in a later stadium there will also be the production of renewable hydrogen through water electrolysis and some power to heat. All of this combined and together with the closure of old coal-fired power plants, this would then in 2050 lead to 30% CO2 reduction. They are all important steps, but it is clearly not enough to comply to the Paris Agreement. And in order to do that, we really need to look at system changes in the port. Luckily, there's three pathways that help us do that. The first is called technological progress, and in this scenario, the EU will focus on 80% CO2 reduction. And if the EU does that, then in the port we will actually, in the end, have 75% CO2 reduction. And how will we do this? Next to all those measurements that were already taken in the business as usual pathway, this pathway focuses a lot on carbon capture and storage. And that will be both on the electricity plants as well as on certain parts of refineries. And actually half of the CO2 emissions in this pathway would be realized by large-scale CCS, which is then also the major challenge in this pathway, because realizing large-scale CCS on such a big scale just hasn't been done before. So it would require lots of investment to make it happen. The Wuppertal Institute thinks Port of Rotterdam is in a good location for it, because we have empty gas fields just offshore. So the CO2 we would be able to store it in empty gas fields offshore, so not on the land where people live, as that has proven to be a sensitive topic for lots of people. The second pathway, and this would be in a world where Europe aims for 90 to 95% CO2 reduction. And the Wuppertal Institute looked at what would the Port of Rotterdam then be able to do, and all the companies in the port, to comply with that. Besides what we saw in the technological progress pathway, is that in this pathway we will see the introduction of large-scale biomass, both for electricity production as well as for fuel production. And my predecessor said alternative fuels is a very important step in this pathway. Those would be biofuels for a certain part, and also biokerosene, for example. In this pathway, we would see more renewable electricity and also the introduction of these new technologies such as water electrolysis again, power to heat, and the production of certain synthetic fuels. So this is the pathway that leads us to 98% CO2 reduction in 2050. Then, last but not least, Wuppertal also thought of a pathway or a scenario in the case that, I forgot to mention one thing. At the last pathway, there's also a major challenge, because each pathway has its own challenges. At technological progress, it was large-scale CCS. We have that challenge as well in the biomass pathway. But then, besides that, there's another challenge, and that is the large-scale availability of sustainable biomass. So important challenge to cover in that pathway. And then last but not least, Wuppertal looked at a different pathway in the case that, well, there would not be large-scale biomass, sustainable biomass available, and it will also not be possible to have large-scale carbon capture and storage. So they looked at what can the port do then in case those two major steps cannot be achieved. That is a pathway which is called closed carbon cycle. This is the scenario in which the port would be most different compared to today. So in those other pathways, the port would be, to a certain extent, very similar to what we know today. In this pathway, it's basically only the chemical production cluster that is still there in 2050, and there would not be large-scale refining and also no large-scale electricity plants in the port by 2050 in this pathway. But there would be a strong chemical cluster, and that cluster would produce the products in a closed carbon cycle, where they would continuously recycle the products. Yeah, and work with that basically. Let me see. Also, a very important step in this one is that it depends very much on 100% renewable electricity. And this is at the same time also the major challenge in this pathway. That cluster that recycles and all those processes, they require lots of electricity. So the cluster in this world would actually need 10 times the electricity we use today. So it would be much more, and it would all have to be sustainable energy by then. So that is the biggest challenge in this pathway, and it would require lots of investments and technology development. For example, getting the process of water electrolysis, so sustainable hydrogen production, making it cheaper, less energy intensive. Those are all developments that this pathway especially needs. As you can see, it's a big picture. It almost looks a bit like a tree. Although this picture is very blue, we do not think of it as a blueprint. We kind of compare it with a map of an average Asian city. Once you look at it, it's already a bit outdated. So we look at it as a guidance, as pathways that we are trying to develop together with our customers, but not as something that has to happen. There will probably be changes and new roads ahead. So how will we do that? Because, of course, commissioning a study is the easy part. Actually, last week we launched the study on an Energy and Transition Summit, and we did that with lots of parties, and most importantly, we did it with our main customers. And at that summit, 120 companies were present, strong Dutch companies representing a large employee base and also a large turnover base. And we actually, together with them, tried to develop all these different steps that are part of these pathways. And we call them coalitions of the willing. These are public-private partnerships where we try to come up with these coalitions and work on the steps that are needed. For example, we have a coalition that works on developing a large heat grid that is to supply heat to 500,000 houses in the area, for example. There's another coalition, let me look at it. Yes, it's called Waste to Chemicals, where we try to work on getting a plant operational in the port that turns waste into chemicals. So these are all examples of trying to work step by step with the companies, also with the authorities in the port, to making decarbonisation happen. This is just a quick overview of the current projects that are in this pipeline, so to say, and also indicating the CO2 reductions that these current projects are actually realizing. That's it. Okay, thank you.